Okay, question 20 is about Newton's laws of momentum. So first of all, we've been asked we've been told that skater A pushes skater B with a force of 30 newtons. So we've been asked to just state what Newton's law tells us about the force that skater A experiences from skater B. So skater A pushes skater B with a force of 30 newtons. That means that skater A will experience an equal and opposite force from skater B. Okay, force in Newton's third law tells us forces always come in interaction pairs which are equal and opposite. So the force is going to be equal. So 30 newtons. But it's going to be in the opposite direction. So for this diagram, if skater A is pushing skater B to the right, then skater A will experience an equal and opposite force to the left, and they're going to move off to the left. Okay, calculate the acceleration of skater B when they are pushed with a force of 30 newtons. So skater B has a mass of 50 kilograms. So the mass is 50 kilograms. The force, we've already been told, is 30 newtons, and we're trying to calculate the acceleration. Okay, our units are fine. We've got newtons and kilograms. So let's put these into the equation. So force equals mass times acceleration. So 30 equals 50 times A. For the acceleration, let's solve for A, so divide both sides by 50. So A is going to equal 30 divided by 50, which should give us 0.6 meters per second squared. So 0.6. Okay, now the next part is about calculating their momentum. Okay. So state the total momentum of both skaters before skater A pushes skater B. So to begin with, they're both stationary. Their velocity is both zero, so their momentum, neither of them have any momentum. So their total momentum is zero. And there's a bit of a clue here. When you get one of these state questions, that normally means that you don't actually need to do a calculation. Okay. And then I should probably put the unit on the end of that, kilogram meters per second. And then the next part is we've been asked to calculate the momentum of skater A. So we've been told that skater A, after pushing, they're going to have a velocity of 2 meters per second. So we just need to so the velocity is 2 meters per second. Their mass, which we can get from the diagram, is 40 kilograms. So we just need to put these values into our equation here. So momentum, I'm just going to use the symbol P for momentum, is 40 multiplied by 2. So their momentum is 80 kilogram meters per second. Okay, and then the next part of the question is to calculate the velocity of skater B after they've been pushed by skater A. Okay, so this is a conservation of momentum problem. That's why there's more marks available for it. So the total momentum before they push each other, which is 0, has to equal the total momentum after they've pushed each other. Okay, so we can write that out as an expression. So total momentum before equals total momentum after. Okay, well, the total momentum before is 0. That's what we set up here. And the total momentum afterwards is going to be the momentum of A plus the momentum of B. So the momentum of A is 80 and the momentum of B is going to equal B's mass times velocity. So that's 50 kilograms, that's their mass there, multiplied by their velocity, and that's what we're trying to find. So 50 multiplied by the velocity. Maybe I'll just put a little b there just to tell us that's the velocity of b. Okay, so the total momentum before has to equal the total momentum afterwards, and the total momentum afterwards is the momentum of skater A, which we've already worked out, plus the momentum of skater B, which is their mass times whatever their velocity is. Okay, now we've got something we can solve. So I'm going to take 80 from both sides. So I'm going to get minus 80 equals 50 times the velocity of B, which means that the velocity of B, if we divide both sides by 50, minus 80 over 50, which equals 1.6 meters per second. So minus 1.6 meters per second. The reason why there's a negative sign there is just because skater B is going in the opposite direction to skater A. So because we've calculated skater A's momentum as being positive, skater B must have equal and opposite momentum to skater A, which is going to give us a negative value, which is why their velocity works out negative. Basically, it means that they're travelling in the opposite direction to skater A. Okay, skater A is going off this way, skater B is going this way. Okay, so the negative sign is just showing it's in the opposite direction to skater A. But we don't need to include that in our answer, so I'm just going to put 1.6. If you did include it, you won't be marked down. So that is question 20.